For number 1, to undo the x squared, to get x by itself, we need to take the square root at both sides, so we are left with x. But the square root of 7 is going to give you a decimal. So we're going to leave that as underneath the square root of 7. You still need that symbol because we did not actually take the square root. And don't forget, we have two solutions, a positive and a negative. Now for number 2, for the second one, we can take the square root of 25, which is going to give you a positive or negative 5. But because of this negative, we need to put I for imaginary. Same thing for this next one, because it's a negative. So we need to have an I in the answer, but 11 is not a perfect square, so we still need to put that underneath the square root. And so plus or minus I, the I needs to be on the outside of the square root. For this next one, take the square root of both sides. Square root of 4 is going to be positive or negative 2. And there is no I because it's positive underneath the square root. And for the last one, take the square root of both sides. We have x equal 0. There is no positive and negative 0. It's simply 0. So there's only one solution. For number 2, what you want to do is be able to get x squared is equal to some number, which means that, like number 1, you can simply take the square root to find the answer. So to make that happen, let's get the x squared by itself first. So first move the negative 74, becomes a plus 74. So we are left with 3x squared. 1 plus 74 is 75. Now we will divide by 3 on both sides. To get the x squared, don't forget to copy down the squared because we have not taken the square root yet, so the square cannot disappear. 75 divided by 3 is 25. Now we can take the square root to get rid of the square. So we're left with x, and square root of 25 is 5. And don't forget the positive and negative. And there is no I because 25 is positive. For number 3, to solve this, we want to get rid of the square. So to undo that, take the square root on both sides. So that leaves us with x plus 3. Now square root of 41, that's going to be a decimal, give you 6 point something. So let's leave that as underneath the square root of 41. But don't forget the positive or negative. And now we just need to move this negative 3 to the other side to get x by itself. So this 3 comes here, becomes a negative 3. Because a positive comes over, becomes a negative, plus or minus square root of 41. That's the final answer. Number 4 is very similar to number 3, but just with fractions. But the steps are the same. So first we need to take the square root on both sides to undo the square. And that leaves you with x minus 1/3. Now on the right side, square root of 5 is a decimal. We give you 2 point something, so leave that as positive or negative square root of 2. That means square root of 5. And then on the bottom, square root of 9 is 3. Now notice how we have the same denominators, so we can combine that when we move the negative 1/3 over to the right side. So this negative 1 comes over, becomes a positive 1, positive or negative, square root of 5, all over 3. For number 5, we will solve by factoring. So remember, each factor needs to equal to 0. So x minus 5 equal to 0, move to minus 5. That is x equal to positive 5. Here we move to plus 7, so that gives you x equal negative 7. For this one, we move the positive 1, so that becomes a negative 1. And then we need to divide by the coefficient, so divide by 2, so negative 1 over 2. Here we need to move the negative 8, so that becomes a positive 8. Then divide by the coefficient, so 8 over 3, positive 8 over 3. Here we move this, so that is a negative 10. And here we have move the negative 2, so that becomes a positive 2 over 5. Here, for this first one, it tells you that x is equal to 0. And then here, x equal, move the negative 2, so that's a positive 2. And for this one, we have, when it's written as x plus 7 squared, that means we have 2 x plus 7s. So move the 7 over, that becomes a negative 7. So the answer for both of them is negative 7. To solve by factoring, we need to make sure the right side is equal to 0, which we have. And that the left side, everything's in order. So a squared plus 9a plus the constant. So that's also good. Now to factor, we don't have anything in front of the a to worry about, so just break up the 18. So we can try 2 times 9. That's 18. And then put the positive and negative signs. So we're trying to get a positive 9, so the bigger number needs to be positive. But 9 plus 2 is 11, and 9 minus 2 is equal to 7. So this does not work. Let's try a different combination. We can try 6 times 3 is also 18. So start with the bigger number. We're trying to get positive 9, so the 6 needs to be positive. And then if we make the 3 positive, 6 plus 3, that's equal to 9. Multiply this, 6 plus 6, positive 6 and positive 3 multiplies to positive 18. So then the two factors will be a plus 6 times a plus 3 is equal to 0. So that means the solution is a equal to negative 6 or a equal negative 3. For number 7, we have 0 on the right side, so that's good. And this is all in standard form, so we have the x squared term, then the x, and then the constant negative 24. So let's put a 1 in front of this. So we have a negative 1 in front of the x. So let's break up the 3. We can do 3 times 1. And break up the 24. We can do 3 times 8. Let's try that and see if that works. Now to cross multiply. 3 times 8 is 24. And 1 times 3 is 3. So we are trying to get a negative 1. So let's make the bigger number negative. But negative 24 plus 3 or minus 3, either way, we cannot get a negative 1. So let's try it again by flipping it now. So instead of 3 and 8, we do 8 and 3 instead. 3 times 3 is 9. 1 times 8 is 8. Start with the bigger number, so the bigger number is going to be a negative. Negative 9 plus 8 is a negative 1, so that looks good. Copy this over. Then double check this. A positive times a negative is a negative 24, so that's good. For the two factors, it's going to be 3x plus 8, which we got from over here. And then the next one is going to be 1x minus 3, but instead of writing 1, we don't need that. We can just go x minus 3. So that means x is equal to move the 8, negative 8 over 3, or x is equal to move the negative 3, which is positive 3. For number 8, we don't have a 0 on the right side, which is what we need to solve by factoring, which means that this 35 needs to move over. So let's make sure we put the left side in order. So first we need the n squared term, so let's copy down 4n squared. Then we need the n term, which is positive 39, so it's already on the left side. Nothing needs to change, but this positive 35 comes over, changes to negative 35. Now we can factor this. Let's break up the 14. 14 we can try 2 times 7, that's 14. And for 35 we can try 5 times 7. Now cross multiply. 2 times 7 is 14, and 7 times 5 is 35. We are trying to get a positive 39, so let's make the bigger number, the 35, positive. But 35 plus 14 is going to be 49. That's too big. And 35 minus 14 is 21, so no matter what, that does not work. So let's try flipping it. 2 and 7, and then 7 and 5. So 2 times 5 is 10. 7 times 7 is 49. Starting with a bigger number, 49 needs to be positive. And to get a 39, let's do minus 10. 49 minus 10 is 39, so that's correct. Copy the signs into the middle and double check by multiplying this. 7 times negative 5 is negative 35, so that's good. Which means that our factors are going to be right here, 2n plus 7 and 7n minus 5. So that means we have n equal to negative 7 over 2, or n equal to, move to the negative 5, so positive 5, then divide by 7, 5 over 7. For this example, we will solve by completing the squares, so copy down the x squared, bring down the 12x term, and then we need to have a blank. So this 4 needs to move to the other side to create that blank, so that would be a negative 4. Bring down the negative 2. Now for the 2 steps, step 1, I'm going to take this 12 and divide it by 2, so which is a 6. And step 2, square that, so 6 squared is 36. Which means that we have to add 36 on the left and 36 on the right to keep the two sides even. So factoring this perfect square trinomial on the left, we have x plus 6 squared, which we got from step 1. Then on the right, we have negative 40 minus 20 plus 36. That's going to be a positive 30. Then to solve, we take the square root of both sides, which leaves you with x plus 6 equal to positive or negative the square root of 30, because that does not come out to be a whole number. And then one last step, to get the x by itself, we need to move the 6 to the other side, so that becomes x equal to negative 6, positive or negative, square root of 30. For number 10, we need to bring down the a squared, bring down the negative 5a. Next, we need to have a blank to complete the square, which means this negative 25 comes over and becomes a positive 25, and bring down the minus 3. So for the 2 steps, let's take this negative 5 divided by 2, which is going to be a fraction, negative 5 over 2. Then step 2, square that. Negative 5 squared is positive 25. 2 squared is 4. So in the blank, we have positive 25 over 4. Because we add that to the left side, we need to also balance it by adding it to the right side, 25 over 4. And now, squaring the perfect square trinomial, factoring the perfect square trinomial on the left side, we get a minus 5 over 2, which we got from step 1. On the right side, 25 minus 3 is going to be a 22, so we have a 22 plus 25 over 4. Now to add this 22 to a fraction, we need to multiply the bottom, 22 times 4, which is 88, and then add the top, plus 25, which is going to be 113. So we have 113 all over 4. Next step, take the square root of both sides. That leaves you with a minus 5 over 2. On the left side and the right side, we have positive or negative the square root of 113, and on the bottom, square root of 4 is 2. So one last step is to move this negative 5 over 2 to the other side. So we get a equals positive 5, because this negative 5 comes over, it becomes positive 5, plus or minus square root of 113, all over 2.